Lesson 17, limits. Okay, we're looking more into limits. And in fact, I was kind of thinking ahead to what I'm going to have you guys do for e-learning next week. And I think we might look at limits with e-learning because that's something we're, kind of starting to learn a lot about. Have you guys logged on to AP Classroom in your other classes yet this year? Yes?
No, but I have to log on to AP Classroom for college stuff.
Okay. Because what it's going to come down to is I don't know if I need to set up the class or if it's already set up, but I need to make sure you guys, when you log into AP Classroom, do you see anything calculus related yet? No. Okay. So I think I need to maybe give you guys the join code. And so probably one day next week we'll do that. Or I guess even if we get a chance today, well, I don't know. I haven't been on my side yet. But I'll probably have an AP Classroom assignment over limits next Friday for the e-learning. Is what I'm kind of thinking. So just, get you guys seeing some questions. Nothing too fancy yet. But, okay, so we are back at looking at limits. And this first set, we're going to look at a table. So let's look at a table of values to see what happens for the following limits. You guys remember how to do tables on your calculator?
We did it earlier.
I say, did we do it earlier this year? I'm trying to remember.
We did it. I was quarantined. So.
We did do it, however. Now, if I recall, okay, we first need to enter, my gosh, my brain's, okay, so first of all, we need to go to y equals and get the equation entered on y equals, if I recall correctly, right? My brain's spacing for a moment. Okay, so I went into my y equals screen. I think this is, yeah. y1, I put 2x over x minus 2. And then, so up above my top row, I have table over on the far. But even before that, we have table set. And I think I'm going to start there because otherwise we're going to be in all places. So I'm going to go into second and the window button which says table set. And we're going to look at, okay, what happens as, what does it say? X approaches negative infinity. Okay, so table start, this just tells me when I first pull up my table what value it's going to be on. So I'm just going to put 0 in there just to put us all in a neutral spot, right? Now, delta table is what the values are changing in. So if I leave this as 0.01, we're going to have 0. That's going to be negative 0.01, negative 0.02, negative 0.03. If we're just trying to get close to like 1 or, something like that, that'd be good. Based on the fact that we're trying to get closer to negative infinity, I'm going to make that table a bigger change value. Does that make sense? So, I'm not sure. I was thinking about like 100, but I'm not sure what that would do. So, I'm actually going to say 1,000. Okay? And you can make this whatever you wanted. You'd still be able to tell the same thing. It's just how effective will it be. And now I'm going to go over into my table, which is second, and the graph button. Fractions are annoying. Sorry, I'm trying to figure out if there's a workaround here that I can... Okay, so the workaround, Ethan and Kayla are so excited. They can enter it as a fraction now. But because I entered it as a fraction, sometimes, not always, but my answers are coming out as fractions. So now, did you guys catch how I entered it though? It's 2x, and I did my divide by symbol instead of a fraction bar. X minus 2 is a denominator with more than one piece, so I had to put x minus 2 into parentheses, right? Anytime my numerator or denominator has more than one term, you put it in parentheses. And so then when I go to graph, okay, now the question is, as x approaches negative infinity, right now you're seeing positive infinity, are you? I wonder if I would have put negative 1,000 if it would have gone the other way. I don't know. Here's the deal. I can just arrow. So, I kind of arrowed up. As my x values are getting smaller and smaller and smaller, right? Negative 1,000, negative 2,000, negative 3,000, negative 4,000. so on and so forth. The question we want to know is, what is y approaching? Can you safely say 2? I mean, I'm at 1.99. I don't know. It might eventually become actual 2.
It turns into 2, but it doesn't go far.
Okay.
Yeah, I'm at 162,000.
Okay. Oh, there we go. 80,000 is when I finally actually hit 2. And at that point, what it is it's still not technically 2. It's your calculator rounding. Your calculator hit so many 9s that it was rounding to 2. So, what are you going to say? The limit as x approaches negative infinity of 2x over x minus 2 is equal to what? 2. And we just showed that using a table. Okay. And if you couldn't read that, that did say as x approaches negative infinity. I know I said it out loud there. And we did that by looking at a table. So if I just put a few values on a table, x of 0, negative 1,000, negative 2,000, negative 3,000. I had 0, 1.996, 1.998, 1.9987. Okay? So thus the table supports that, right? Okay, let's try the other one. This one, can you guys read it? This one says as x approaches positive infinity of 1 over x. We're going to look at a table again. So, you guys know what to do on your calculator? Oh, sorry. I guess I'm really zoomed in and you can't see what I'm writing, can you? Sorry. Better? I mean, I was saying everything out loud, but I know it's better to see it. Okay. So when you're ready, try number 2. So first of all, I'm going to go to y equals, and I'm going to change it to 1 divided by x, because I don't want to run into that fraction issue again. I just used a division sign, right? If you just go straight to your table, it's going to probably pick up wherever you left off, isn't it? So my recommendation is you go to table set. Yeah, because my table start is negative 84,000. I'm going to make my table start 0. Mm-hmm. 1,000s could still work, I think. We'll try and see what happens. Then I'm going to go into my table. Excuse me while I play for a moment. Okay. I backed off and went to 100s. Okay, so at 1,000s, it was all showing in scientific notation, right? Which just makes it harder to visualize. So I went in and changed my delta x to 100. I think it's a little bit easier to see. But so what are we looking at? As x approaches positive infinity. So as x is getting bigger and bigger, what is my y value getting closer and closer to? Oh, and right there at 1,000, it goes 0.001. And then it goes to scientific notation. Now, if you watch the scientific notation, for a while it has a negative exponent of negative 4. Eventually, I'm going to have to get up to 10,000, I think. But you'll have an exponent of negative 5. What's happening here? Yeah, once I hit 10,000, now I'm at an exponent of negative 5, which means there's even more decimal places, right? Approaching 0, right? The more decimal places of zeros we get, we're approaching 0. So, and on this one, honestly, even if we do this one without the calculator, think this way. If we put 1,000 in, 1 over x, so 1 over 1,000 is 1,000, as in 0.001, correct? What if we put in 10,000? That's 1 over 10,000, which is 0.0001. 1 10,000. What if we put in 100,000? 0.00001. Is that maybe a better effect? Okay. And on the calculator, it's just a set delta x, right? Or at least to my knowledge. It'd be nice if we could make it like increase decimal places or something like that, but I don't know a way to do that. Okay, so that's just, we're exploring with the table there. Honestly, graphs are going to be more, and equations are going to be more what we look at, but, And as much as what we want to use a calculator, we also don't want to rely on the calculator, right? Half your AP test is non-calculator. More than half the multiple choice problems are non-calculator. Okay, I mean, in terms of points, I think, it's half of the AP is non-calculator, but, more than half of your AP or the multiple choice part is non-calculator. So we have to be able to, okay, how do we do these limits without being able to graph something on my calculator? Without being able to put the limits in. So, okay. When we've done limits before, if it was x approaching 3, one of our tricks was we could just take 3 and plug it in, right? Now, if we got something like 0 over 0, then we had to hope it factored or something. We had to hope something would happen that could help us. Now, so as x approaches infinity, there's some tricks we can do because it's kind of a little different thinking about, okay, I'm going to plug infinity. What happens when I get infinity over infinity? Some things like that. So first of all, when you plug infinity in, if you have, say, 1 divided by infinity, or any constant number, even if it's 1,000 divided by infinity, infinity means that denominator is getting bigger and bigger and bigger, right? And if you had a constant solid number on top, and that new denominator is getting bigger and bigger and bigger, what's happening to that fraction? That fraction is getting smaller and smaller and smaller, and thus it is approaching 0. We're not saying it's going to necessarily equal 0, but it's getting closer and closer and closer to 0 the bigger that denominator gets. And that's if your numerator is just a constant number. Whether it be 1, whether it be 5, whether it be 5,000, it's a constant number. Okay? Now, the flip side. When you have infinity divided by a number. Okay, again, that's a constant number, right? If you have infinity and you're dividing by that constant number, the bigger that numerator gets on top, divided by some certain number, then the bigger that result gets. And so infinity just divided by a constant is represented as infinity. And then we'll look at some techniques here. But as we talk about infinity divided by infinity, okay, generally speaking, it's eventually going to approach 1. Okay? And this is where we're going to have to look at the biggest powers. So again, I'll expand on that as we go through some examples. Okay, that's the best I can say there. Is I'll expand as we look at some examples and get you guys headed in the right direction. So, as we look at example 1, the limit as x approaches infinity of this fraction. So if you just plug infinity in, it's 4 times infinity squared plus infinity plus 6 divided by 3 times infinity squared plus 1. Say what? Okay, and this is where we can't just fully plug infinity in just, as is. And so the technique we're going to use, and this is when we're approaching infinity, is we are going to go through, and you'll figure out the shortcut eventually, but we're going to divide by the highest power that exists in the denominator. So x to what power is the highest power in the denominator? X squared, right? So, let's see. First of all, let me put a comment here that we are going to divide by highest power in the denominator. So in this case, that is x squared. And we're going to do this the long way right now, okay? You guys know, right? We got to understand how this works. So what we're going to do is we're going to redo this limit. But since x squared is the highest power, we're going to take each individual term and divide them by x squared. So as I write this out, it's going to still be the limit as x approaches infinity. And we're going to take 4x squared and divide it by x squared. Plus x and divide it by x squared. Plus 6 divided by x squared. We're going to do the same thing on the bottom. 3x squared divided by x squared. Plus 1 divided by x squared. Okay? And as I said, this is not something you have to write out every time. Excuse me. Now, let's do some cleanup, and then we'll talk about what each of those limits look like. So if I could do some cleanup, the limit as x approaches infinity. What do you know about 4x squared divided by x squared? It's 4. Plus, what about x over x squared? Be what?
Would it be, could you do 1/2 or could you just do
1 over x. Okay. And then 6 over x squared is just going to be 6 over x squared, right? And then denominator, 3x squared divided by x squared is 3. Plus 1 over x squared is just 1 over x squared, right? So what are we doing here? We're trying to plug in infinity. So every place you see an x, we're going to plug in infinity. You got it? So that means right here, where it's 1 over x, we're going to think 1 over infinity. Where it's 6 over x squared, we're going to think 6 over infinity squared. And where it's 1 over x squared, we're going to think 1 over infinity squared. Got it? Okay, in other words, now that I've done some pre-work, we're ready to plug infinity in. Now, okay, 4. Does infinity affect 4? No, 4 is 4. So on top we have a 4 plus 1 divided by infinity. What is 1 divided by infinity? That's going to be approximately 0. Plus, what's 6 divided by infinity squared? It would also be 0. 6 is a constant number, right? Infinity squared technically isn't any different than infinity. It's an ever-increasing larger number, right? So if you have a constant 6 divided by some bigger and bigger number, that is 0. Okay, denominator. 3 is 3. 1 divided by infinity squared. 0. Okay? Got the really difficult math left here. 4 plus 0 over 3 plus 0. Sorry. Get the sarcasm there, folks. 4/3. Okay. So the limit as x approaches infinity of this lovely expression is 4/3. Now, shortcut. Do you see a shortcut? What do you see, Abby?
Well, I was just kind of thinking if everything's going to turn out to be 0 except for the things that are like x squared, I could just forget about everything else and just focus on the 4 and 3.
Pretty much. Okay. All those smaller powers aren't going to matter because all those smaller powers are going to end up going to 0. Okay, it's going to be your top powers that matter. Notice in this particular problem, my powers matched, didn't they? Okay, my powers matched, and so it really just turned into being the coefficients of the highest powers. Where else have we used coefficients of the highest powers? This is a horizontal asymptote, folks. As x approaches infinity is, okay, what is my graph doing as it goes out to infinity? Okay, so as x is going out to infinity, what y value is this approaching? Well, it's approaching whatever this horizontal asymptote is. Okay, and in this case, the horizontal asymptote was 4/3. So if you recall, horizontal asymptotes, if the powers are the same, you just use the coefficients of those matching powers. Okay, if the highest powers are the same. So yes, that is a valid shortcut. Okay. Other questions there? Maybe not yet, right? Okay, let's try example 2. Now, I'm going to take you the long way still, okay? Yes, start noticing the shortcuts, but I'm still going to take you the long way. The limit as x approaches, what's that say? That's a negative infinity. Squint carefully, right? Of x cubed plus 6x over 8x squared plus 5x. Now, let's go with the same technique from earlier. Divide by the highest power in the denominator. So what's the highest power I'm going to divide by? X squared. So we're going to divide all terms by x squared. And yes, I'm going to write this out for the purpose of our notes. Okay? So, the limit as x approaches negative infinity. Now, do you want me to go ahead and simplify as we go rather than writing it out fully the long way? Or not? Okay. So if we do x cubed divided by x squared plus 6x divided by x squared all over 8x squared divided by x squared plus 5x divided by x squared, right? That's the long way, right? Now if we do some cleanup, limit as x approaches negative infinity, a helpful calculus tip. I know it's annoying, but always rewrite that word limit and what x is approaching. Just because if you start skipping over writing that word limit, you start forgetting it's a limit. You forget that that's what we're doing. Okay, so it's always helpful just rewrite that. X cubed over x squared is going to simplify to x. 6x over x squared is a 6 over x, right? 8x squared over x squared is 8. 5x over 5x over x squared is 5 over x. What am I plugging in this time, so to speak? Negative infinity. Okay. So, plugging in every place I see an x, I'm replacing it with negative infinity. Well, if x is x, and I plug in negative infinity, that is negative infinity. Plus, what about 6 divided by negative infinity? You ready this time? Yeah. Yep, that's fine. Okay, what do they ask? 6 divided by negative infinity? It's 0, right? Positive infinity, negative infinity, in this situation, as you have a constant, and ever increasing, whether bigger or smaller, it's still going to be approaching 0. Over 8, which is 8. 5 divided by negative infinity is 0. So I essentially end up with negative infinity over 8. Which is equal to what? Negative infinity. If we've been plugging in positive infinity, it'd be equal to positive infinity. Yeah. Yes, you do get the pink paper. Good question.
Yeah, both have to panic.
Nope, you get the pink paper.
Okay, thank you.
You're welcome. Now, shortcut here. If you notice the original powers, the bigger power was on top. And so since the bigger power is on top, it's going to be infinity or negative infinity, depending on what you're approaching. Okay? So yes, you can still use, that shortcut. However, do we have the backups here? You have the backups, you can think about them that way. If we divide out the highest power, look at it that way. And of course, example 3. Oh, and by the way, when the biggest power was on top, what did we say about horizontal asymptotes? We said there weren't any. Okay? So that's what this graph is doing, is this graph, as x is getting smaller to the left, this graph is going infinitely down, is what this is saying. Okay? As x gets smaller, so as the graph goes farther left, my y values are getting more negative, which means they're going down. So there's no horizontal asymptote here, is what this is saying. Okay? So if there's no horizontal asymptote, my graph's either going up or down. Okay? Example 3. Officially, what am I going to say we need to do? It's the limit as x approaches infinity, so divide by x squared because that is the biggest power in the denominator, right? So the limit as x approaches infinity. (5x over x squared) plus 7 over x squared divided by 13x squared over x squared plus 10x over x squared plus 2 over x squared. More importantly, the cleaned up version, right? 5x over x squared (5 over x) plus 7 over x squared is 7 over x squared over 13, 10 over x, and 2 over x squared. And what am I plugging in for x? Infinity. Okay. What about 5 divided by infinity?
0.
0. 7 divided by infinity? Okay. In the denominator? I've got 13. Well, at this point, you've got it. We've got 0 over something other than 0. So, no, it exists. It's 0. 0 over anything other than 0 is 0. Okay, so what this is saying is that as x goes off to the right, there's a horizontal asymptote at the y-axis, is what this is saying. I'm getting closer and closer to the y value, horizontal asymptote at the x-axis. I'm getting closer and closer to a y value of 0. Okay?
When the shortcut is the bigger powers on the bottom. 0.
Correct. I almost forgot that. Important part, right?
So we still have to work out on the test.
Not necessarily, no. No, you do not necessarily have to work them out. You definitely don't have to show as much work as I'm showing here, right? This is the intro. Here's the hows and whys and how we think it through. Okay. Honestly, what I tend to do here is I'm going to block out the rest of the problem. I'm just going to look at the biggest powers. Biggest power on bottom, I know it's going to be 0. Biggest power on top. And remember, this is as x approaches infinity or negative infinity, right? If it's x approaching a number, that's a whole different story. Okay, but this is for when x approaches infinity. Okay? Okay, and the graphs would reinforce this. I haven't been taking the time to pull the graphs up, but the graphs would reinforce this. Now, okay, let's look at the following limits on a table of values and on a graph. Honestly, I think I'm just all about the graph on this one. Yeah, let's focus on the graph here. We already talked about table of values some, didn't we? So let's focus on the graph. You can go ahead and graph on your calculator if you want. I'm just setting up to graph this in my notes. So, y equals, I can go back to using my fraction bar now, 1 over, parentheses, x minus 2, quantity squared, okay. Got it? Did you get a graph? Any thoughts here?
I'm assuming that's like an asymptote going down the middle, which is why it's not touching the side. It doesn't ever hit 0, right? Or doesn't ever hit 2.
Okay, so yes, this is definitely the makings of an asymptote. Okay, and you need to, at calc level, you need to be able to look, okay, yeah, I see there's a vertical asymptote. Where is this vertical asymptote? 2. How do we know?
Because that's the line they're both not hitting.
Okay, that's the line they're both not hitting. And you can kind of use trace to help you figure that out, right? How does my equation tell me that it's 2?
Because x can't be 2 because if you have 2 on the bottom for x.
Yeah. Remember setting that denominator equal to 0? That's going to find a whole and or vertical asymptote because there's no x minus 2 on top to cancel it with. This is saying that there is a vertical asymptote at 2. Okay? Your calculator doesn't show you vertical asymptotes, so you need to understand that that's at 2. And how to, whether you use a calculator to trace it, or what you do there. Now, graph looks something like this. And this is saying, as x approaches 2, what is the limit here? So as I trace my graph, and I get closer to 2, what is this side doing? It's going up. What y value is it approaching? If it's going up, it's approaching infinity. Now, what about from the right, though? As I approach 2 from the right, it's also going up in infinity. Since both sides are approaching infinity, we can say that the limit is infinity. Okay? Because it didn't specify as x approaches 2 from the left or the right, we have to check both sides to make it work. Make sense? Okay. So, now let's regraph it. Basically drop off the square, right? Okay, so now, similar graph, yes, except one of them flips. Still a vertical asymptote at 2, yes. I know there's a vertical asymptote at 2 because A, I can trace it on my calculator, and B, set that denominator equal to 0, right? That tells me that there is something happening there. Now, graph looks something like this. As x approaches 2. So, as x approaches 2 from the left, What y value is this graph approaching? It's getting smaller and smaller and smaller, going down, 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 so negative infinity. Okay? From the right, as x approaches 2 from the right, what y value is my graph approaching? Positive infinity. Are positive infinity and negative infinity the same thing? No. What do we get to say the answer is? The limit does not exist. Or undefined is what you'll also sometimes see. Okay? Exist. Okay, so be familiar with that terminology. Undefined, limit does not exist. DNE is an abbreviation for does not exist. Sorry, I know it took us all this time to get to a limit does not exist one, but you knew it had to be there somewhere, right? Okay. One more. Find the limit as x approaches, find the limit of negative of 1 over x plus 3 quantity squared as x approaches negative 3. Now, so in limit notation, that means the limit as x approaches negative 3 of negative 1 over x plus 3 quantity squared. That's what we're trying to find. And this is where, notice, and on even the ones up above, what happens if we just plug the number in? Negative 3 plus 3 is 0. 1 divided by 0? No, not 1 divided by 0. Okay, so 1 divided by 0, and here's something to take to account here. Up on the very first example, 1 divided by 0 turned out to be an infinity, a positive infinity. Here, 1 divided by 0 turned out to be a undefined or does not exist. So is there a set answer when 1 is divided by 0? No. Okay, you have to consider the graph. You have to consider from both ways to decide. Maybe it's infinity, or maybe it does not exist. Similar thing is happening here, right? Where's the asymptote this time? Okay. And your graph should support that, right? I haven't graphed mine yet. I will do that. Make sure you use a negative out front. Negative of 1 over x plus 3 quantity squared, or that negative could be with the 1. Okay. Is this supporting an asymptote at negative 3? Definitely is. So this time, yep. We agreed there? As x approaches negative 3, so you have to approach from the left and from the right. Since they are both going down, we can say negative infinity. Okay? Okay. 4 limits, right?
Honestly, the limits thus far are easy.
I like limits. I really do.
Now, derivative is just like, for me,